Okay, we'll come back. Just now we did told about star delta transformation or delta star transformation, right? So how we'll combine this here? You little bit you just see how things are, right? So if you look at the circuit, suppose for example a bridge circuit is given in your figure 40. So how do you combine resistor R1 through R6? I would say simple bridge circuit is there, and here you have resistance R1, R2, R3, R4, R5, R6. So how can you combine this R1 through R6, right? So in that case you will find it difficult to get series parallel combination because the way their connections are, right. So you have to simplify by using a 3 terminal equivalent networks, right. We generally consider 3 terminals equivalent network. For example, your this thing, just hold on, for this one. So 3 terminal means basically these 2 terminals, look into that, these 2 terminals actually is common. Basically this is one terminal and this is another terminal, and 2 and 4 because basically it is a common terminal. So it is not 4 terminal, it is a 3 terminal, right, and resistances are given say R1, R2, R3. If we draw like this, we call star connected, right. Same circuit, if you stretch it up and make it like this, same circuit, both are same, it is sometimes we call T network. Here also R1, R2 and R3, just this point you stretch it up, right, and just make it draw like this R1, R2, this is sometimes we call T network, and this is we call a star, both are same, right. So this is basically a 3 terminal because this is common terminal, 2 and 4 is a common terminal. So let me clean it, right. So that is why it is star network we call, sometimes they call Y network also, and this is T network, right. So another thing is the delta or pi network, right. So this is actually this is sometimes we call delta network. Here also 2 and 4 are common terminal, here also this 2 and 4, this is a common terminal. So it is basically 3 terminal, and 1, this is actually this this is 2, 3, 4, this is marked, but this is basically a 3 terminal. And if you just bring this point to somewhere here and bring this point to somewhere here, this looks like your pi network. So because this is a common point, right, this is a common point. So this is looks like a pi network, both are same. Sometimes we call this is delta network and this is we call sometimes pi network, but both are same, right. So that's why it is written delta network and this pi network. So how to, because basically we have to either start to delta and delta to star conversion. So how we do this? Just hold on, right. So now delta to star conversion, right. We have to, so in this case what we will do, we have to superimpose a star network on the existing delta network and equivalent, and you have to find out equivalent resistances in the star network when you go for delta to star conversion, right. So for obtaining the equivalent resistance in the star network, the resistance between each pair of nodes in the star or T network is the same as the resistance between the same pair of nodes in the delta or pi network. Now how it looks like? Now let us first try to find out, right. For example, for terminals 1 and 2, if you go for star network, for terminals 1 and 2, 2 and 4 is common. So I am making it here that 2 and 4 is common, right. That means we make it as I say your what you call forget about this side, say take R12, that means your R12 when this side is open, so R12 will become actually R1 plus R3 because this is R1 and this is R3, right. So R12 will become R1 plus R3. So just clean it and let me go, right. So if you see this, that R1 to star is equal to R1 plus R3, right. This is your for star connection R1 to star, R1 plus R3. Now if you look R1 to delta, right, come here again, when you come to R1 to delta here, right, here when you come to, forget about this thing, that R1 to delta, this side nothing is connected, right. That means if you look into here, you will find that if it is that if you try to find out here R1 to this delta, means for delta connection, right. That means RC and RA, they are in series, right. That means RA plus RC in parallel with RB. That means we can write this one is equal to, hope you can this thing, that RA plus RC, these two are in series, RA plus RC, with that parallel to this, on this I am making it parallel is RB. That means R12 delta will be RA plus RC into RB divided by RA plus RC plus RB, right. So, because as soon as we are taking your what you call R12, please do not consider anything here. It is simply RA and RC. It is this as if it is open. So, this side nothing is there, right. So, RA plus RC they are in series, along with that RB in parallel. So, it will be RB into RA plus RC divided by RB plus RA plus RC. So, cleaning it and going to that, right. So, if you come to that, sorry, that look, R12 delta is equal to RB parallel to RA plus RC. That means RB into RA plus RC by RB plus RA plus RC. Now, both are, both are actually same, R12 star and R12 delta both are equal. Just we said that setting R12 star is equal to R12 delta, because you have to find out equivalent, hence they will be equal. Therefore, R12 will be R1 plus R3 will be RB into RA plus RC by RA plus RB plus RC. This is equation 42. This all equation number 40, 41 is given. So, one equation you got R1 plus R3 is equal to this one. Similarly, when you get your R13, you come to this circuit. When you come to your R13, right, this one when you come, that R13, that means just hold on, this is 1 and this is 2. When you try to find out R13, it is actually R13, then it is star, right. Basically, it is nothing but R1 plus R2, because other side is nothing is there open. So, it is R1 plus R2, right, R1 and R2. This is your R13, and when you this is for star. Now, when you come to delta, let me clean it. When you come to delta here, right, here when you come to R13, let me mark it, right, this is your 1 and this is 3. When you coming out to your R13, that means in that time RA and RB are in series, right. Therefore, R13 delta, right, is equal to your RA plus RB. This is in your what you call, this is these two are in series, and with that with parallel with RC, that means it is RA plus your RB, right, this one into, I am writing on it, does not matter, into RC divided by RA plus RB plus RC, because when you take 1 3, this RB and RA they are in series, right. So, just cleaning it. So, that means your when to take R13, RA and RB are in series, and that is RA plus RB, with that RA plus RB is in parallel with RC. So, it will be R13 delta will be equal to RA plus RB into RC divided by RA plus RB plus RC, right. So, that is why you are writing this equation, your R13 is equal to R1 plus your what you call R2 into RC RA plus RB by RA plus RB. This is equation 43. Similarly, third one R34 also similar way you can find out. I need not repeat it again. Now, things are understandable to you, right. Similarly, R34 if you make, it will become R2 plus R3 for star, and for your delta you will see RB plus RC is in parallel with RA. So, because RB and RC will be in series, so RB plus RC into RA divided by RA plus RB plus RC. So, if you look into that equation 42, equation 43 and 44, that 3 unknown and 3 equations, you have to solve it. So, I am writing the solution directly, but you can try to solve of your own if you want, right, but no need actually, some technique is there, I told you, you can keep it in your memory, right. So, solving 42, 43 and 44 for R1, R2, R3, you will get R1 is equal to RB RC upon RA plus RB plus RC, R2 is RC RA by RA plus RB plus RC, and R3 is equal to RA RB by RA plus RB plus RC. So, from your what you call, how to remember this one, right, the delta to star, right, how to remember this one. So, go back to this thing, right, the delta to star transformation, right, go back to this. Now, look into that your what you call your 1 to suppose R1, R2, R3, and here it is your RB, RC, RA, right. So, if I superimpose this star, on this delta, then how it looks like? Just see that when I am making it, hope it is matching with this your this thing. Just hold on, just hold on. Let me have a look. This one R1, R2, R3. Okay. Now, just hold on. This is actually, if you try to find out, this is R1. This is actually, this one actually your R1. This is actually your R2, and this is actually R3, right. So, R1 will be, look, according to that, R1 will be, this is your R1 and this is delta. So, R1 will be RB RC divided by RA plus RB plus RC. That means, when you take the R1, the product of these two resistors adjacent branch divided by sum of all RA plus RB plus RC. Similarly, R2 is equal to product of the two resistor adjacent branch, that is RA RC divided by RB RA plus RB plus RC. Similarly, R3 is equal to product of the adjacent branch, that is RA RB divided by your what you call RA plus RB plus RC, right. So, this is your, if you go to that, the derivation, that R1, look, R1 is equal to RB RC, RA plus RB plus RC, R2 is equal to RC RA, RA plus RB plus RC, R3 is equal to RA RB, RA plus RB plus RC. That means, I told you that adjacent for adjacent branch product resistance divided by RA plus RB. I mean, all the time your R1, R2, R3 case are division by RA plus RB plus RC common, and only adjacent branch that two resistance product you have to take, that is your delta to star conversion, right, delta to star conversion. So, that is 45, 46 and 47, this is the equation number, right. Now, question is, superposition of Y and delta network is shown in figure, this thing, here it is shown, whatever I shown, look, R1 is equal to, when you take R1, product of this adjacent branch RB RC by RA plus RB plus RC. Similarly, your R2 is equal to product of this adjacent branch RA RC by RA plus RB plus RC, and R3 is equal to RB RA RB divided by RA plus RB plus RC, that is whatever it is written here in 45, 46 and easy to remember. And one additional node is created neutral, that we will see your end, that we will see later for the AC circuit, not here, we will not see those things here, right. One another additional node is created here N, right, that we will see later, right. But for our this thing AC circuit analysis, but your what you call, this is your delta to star transformation, this is actually delta to star transformation. Now, star to delta, if it suppose R1, R2, R3 is there and star, I have to make what is the expression of RA, what is the expression of RB, what is the expression of RC, right. So, that how we will do it, that now star to delta transform. Now, I have a star network. Now, what I have to do is I have to convert it to delta network, right. So, in that case what you do, that for your Y network, that equivalent delta network we made from equation 45, 46 and 47. Look, here we have R1, R2 and R3, all three expressions. What you do, you find out the sum R1, R2 plus R2, R3 plus R3, R1, R1, R2 multiply, R2, R3 multiply and R1, R3 also multiply and add, right. If you do so, then R1, R2 plus R2, R3 plus R3, R1 if you and simplify, you will get RA, RB, RC into RA plus RB plus RC upon RA plus RB plus RC whole square. So, RA plus RB plus RC will cancel, ultimately it will become RA, RB, RC upon RA plus RB plus RC, if you just make it. Now dividing equation 48 to, that is 48, that is by each of equation 2, 45, 46 and 47, then we will obtain. Then what we will do, this equation 48 divide by each of 46, right, this one, that your equation for your 45, 46 and 47, just you divide, right. This is the simplest way of obtaining this, right. You got this one. Now, dividing equation 48 by each of equation 45, 46 and 47. So, first you divide equation your 48 by your 45, first you divide, then what you will get? You will get this your R A is equal to R 1 plus R 2 plus R 2 plus R 3 plus R 3 plus R 1 divided by R 1, right. So, what we will get this one, that R A is equal to R 1 R 2 plus R 2 R 3 plus R 3 R 1 by R 1, and R B is equal to R 1 R 2 plus R 2 R 3 plus R 3 R 1, and R C will get R 1 R 2 plus R 2 R 3 plus R 3 R 1 by R 3. But how to remember? I will simplify it this way. If you just make it like this, the R 1 R 2 plus R 2 R 3 plus R 3 R 1, all the case numerator in this case is same, this R 1 R 2 R 2 R 3, all the case numerator is remain same, only for R A divided by R 1, for R B divided by R 2, and for R C divided by R 3, right. So, if you look into the circuit, that your what you call your start to delta transformation, right. So, this is if you look into this, that what will be your what you call that your R A, R B and R C. If you look into that your R A, then R A is equal to, actually it is coming that numerator is same, R 1 R 2 R 3 R 3 and your R 1 R 2, then R 2 R 3 R 3 R 1 divided by R 1. So, how to remember this? So, question is that your, for example, this one, look, for first I am taking R A, right. What we are doing is, that is your R 1 R 2, this numerator is common, R 1 R 2 plus your R 2 R 3 plus R 3 R 1 common, divided by, this is R A, right. So, and this is the opposite arm, here it is R 1, you divide it by R 1, right. Now, for further simplification, how we will do? Divide this one by R 1. So, it will become R 2, right, and plus this is your R 2 R 3 by R 1, and divide this by R 1, this is R 3. That means, R A is equal to, I can write like this, R 2 plus R 3 plus R 2 R 3 by R 1, right. That means, for remembering this, that R A is equal to, what you can do is, one is that very simple is that your R 1 R 2 R 3 plus R 3 R 1 divided by the opposite, this R 1, just opposite to this R 1, right. Another way is R A is equal to this adjacent branch, this sum, that adjacent branch R 2 plus R 3 plus R 2 R 3 divided by this opposite branch R 1. So, R 2 plus R 3 plus R 2 upon R 3 upon R 1. This way also you can remember this, I mean this is the simplest way, that R 1 R 2 R 2 R 3 R 3 is common, numerator is common. So, when you take R 1 R A should be this R 1 R 2 R 2 R 3 R 1, this is common, divided by R 1. Similarly, if you try to find out your what you call R B, similarly numerator is common, actually whatever will come divided by your R 2. Similarly, when you take R C 1, that numerator is common, right, divided by only R 3, very simple. Otherwise, R A is equal to your what you call R 2 plus R 3 plus, see after simplification this R 2 into R 3 by R 1, the way you want. Similarly, your R B and R C you can easily make it, right. So, it is very easy the way you want, but I always feel this is the simplest one, because product R 1 R 2 R 2 R 3 R 3 R 1 product you take, and this is common for all, this is common for all the your what you call for all R A R B R C, numerator is common. So, just when it is R A, just opposite branch is R 1 divided by R 1, when it is R B, whatever it is coming numerator divided by R 2, numerator is same. Similarly, for your what you call R C, whatever numerator is common divided by R 3, the simplest one. I hope you have understood this, right. So, just you have to solve it, that is all. So, just cleaning it, right. Hope things you have understood, that how to make this thing, right. So, this is your start to delta conversion, right. So, each resistor in the delta network, I made something underline, that is the sum of all possible products of star resistances taken 2 at a time divided by the opposite your Y resistor, the opposite Y, that's all, right. So, this is easy for you, right. And if in this case, if suppose delta and star networks are said to be balanced, I mean when R 1 R 2 is equal to R 3 is equal to R star, that means when all are equal, it is said is a balanced network, right, and R A R B R C is equal to R delta, right. So, that is equation 53. So, under this condition, if you make all are same, right, R delta and R star all are same, then easily you can find out with conversion. So, R star will be R delta by 3, right, when you when you making for your what you call the one you can make it delta to star, another you can make star to delta, right. So, in that case R star will be R delta by 3 or R delta is equal to your 3 R star, right. So, from this equation only it comes opposite to that, R delta is equal to 3 into R cross multiplication, right. So, this is the that is fine it is all R1, R2, R3, RA, RB, RC all are equal, then in that case this is the condition, you simply substitute and do it, that is all, right. So, star or delta networks occur by themselves or as a part of the larger network. They are used in the your 3-phase network, matching networks and electrical filters, that will your what you call that when we will run 3-phase circuit, at that time of course we will see the star delta, right. So, next let us take one example. So, in the circuit shown in figure your 44, so find the equivalent resistance RAB, right, and the power delivered by the same, right. So, in that case that you have to find out this is actually A terminal, this is actually B terminal and voltage source is given, and you have to find out first what is RAB equivalent resistance of this circuit, first you have to find out, right. So, how we will do it? Now, 10 and 6 ohm actually they are in series, so it will be 10 plus 16. So, 10 and plus 6 these two are in series, so it will be 16 ohm, right, and with that 48 is in parallel, right. So, 16 is in parallel with 48. So, equivalent will be 16 into 48 divided by 16 plus 48 ohm, right, whatever it comes. So, same thing is there next. So, let me clean it. So, if you look so 10 6 read this thing and 48. Now, if you look into, I told you that 10 and 6 are in series. So, 16 and 48 are in parallel, right. So, this 48 and 16 will be parallel, equivalent is becoming 12 ohm, right. So, that means the circuit is coming like this, this is your 12 ohm and then again 12 ohm is in series with 18 ohm, because 18 ohm resistance is here. So, here it is 12 and 18. So, 30 ohm total, that is in parallel with 15 ohm, right. So, 15 into 30 by 15 plus 30. So, equivalent to 10 ohm, and power delivered is we know V square upon RAB, because equivalent this is actually RAB equivalent resistance, because this terminal is A, this terminal is B. So, this is equivalent to your what you call this equivalent is your this is actually A, this terminal is B. So, this equivalent is RAB, right. So, RAB is equal to your 10 ohm, because 12 by 30, 30 into 50, 12 and 18 30, 30 into 15 by 15 plus or 30. So, 10 ohm, right. So, cleaning it. So, it is actually 40 watt. So, power delivered by this one is 40 watt, right. Now, next is your another thing, that convert delta network to an equivalent star network, that it is RA is given 15 ohm, RB 20 ohm and RC you have to convert star to delta. So, this is actually drawn R1, R2, R3. So, just for your this thing, just hold on, this is RC no. So, it is A, B, C, A, B, C all are marked. So, A to B actually here it is RC, right, and here it is your this branch is RA for delta and this branch is RB for this thing, right. So, it is 25 ohm, 15 ohm and 20 ohm, right. So, this is I am cleaning it. So, if you use equation 45, 46 and 47. So, R1 will be RB RC by RA plus RB plus RC, RA RB RC all are given, right, just to by adjacent band product divided by RA plus RB plus RC, that is all, right. So, it is RA is RB plus RC sorry RB into RC by RA plus RB plus RC, whatever it comes, 20 into 25 by 15 plus 20 plus 60. So, denominator is 60. So, it will be 25 by 3 ohm. Similarly, R2 is equal to RC RA, denominator is fixed. So, 25 into 15 upon 60. So, 25 by 4 ohm sorry, and R3 is equal to RA by RB and denominator is fixed. So, it is total 60. So, 15 into 20 by 60. So, that is equal to 5 ohm. that is delta to star conversion. So, taking R1, R2, R3 in star, try to convert to delta, same value you will get RA, RB, RC. Right. Now, another thing is that transform the T network. T means it is a star network, right. So, T network in figure 48 to your what you call to your delta network. So, it is a star, right. So, making it delta. So, this is your A, just hold on, this is A, B and C, right. This is T network with star network, R1, R2 and your R3 all are given 10, 20 and 30 ohm, right. Now, delta, when you are trying to make it delta, right. So, this is actually your R1, this is actually your, if it is R1, I think this is R2 and this is R3, yeah, this is R3. So, right. So, cleaning it. So, you are making this your what you call this you have to convert it to your what you call to delta. So, RA is equal to, told you, you will take that your what you call all the product R1 R2 plus R2 R3 plus your R3 R1 divided by the opposite arm of the star, that we have seen. So, in this case also right, just 1 minute, let me check, I should not make any error, right. So, this is R1, this is R2, this is R3, now it is okay. So, now this is your, this is R1, this is your R1, this is R2 and this is R3, right. So, we have to your what you call that star is given. So, we have to make it delta. So, we know RA is equal to your R1 R2, numerator is same here, R2 R3 plus R3 R1, right, divided by that opposite arm R1. Similarly, RB RC will be get, all the values of R1 R2 R3 is given. So, you can easily compute. So, let me clean it, right. So, look into that equation 49, 50 and 51, RA is equal to R1 R2 plus R2 R3 plus R31 by R1. So, just 10 into 20 plus 20 into 30 plus 30 into 10 divided by 10. So, it comes 110 ohm. Similarly, RB is equal to, numerator will remain same, divided by R2 20. So, 55 ohm, and this one your what you call numerator will remain same, divided by R3 30, it will be 110 by 3 ohm, right. So, this is another circuit that for the network in figure 50, find RAB and I. Just one thing here, one small error is there. So, this actually you have to find RAB means this RAB, here this you ignore, this one you ignore. So, I cut this is not there. So, I cut RAB means this RAB, right. So, in the diagram this you ignore, by mistake I have made it here also, but you have to find out this RAB. So, how to find it out, right. So, and the I current voltage source is given 50. So, 24 ohm, 20 ohm and 10 ohm resistor are delta connected, and for simplicity convert delta network portion to star network. 20 ohm, 24, 20 and 10. So, 24, 20 and 10, this is basically your delta, because C and B, if you just make like this, it is a delta connection. It is made it like a square, but it is a delta connection, because here you can make this connection like this, right. So, only I am drawing this portion, this is C, this is your C, right, and this is your some terminal, this is your some terminal. I should have made it A dash B dash, then there is no problem, right. So, here it is A dash, right, here it is B dash, and this is 10 ohm and this is your 10 ohm, and here also that 30 ohm is connected, and here also some 50 ohm is connected, something is. So, this actually it is in delta, right. So, 24, 20. So, you have to convert it to star, right. So, you can now you know how to convert it to star. I will not, I will directly I will give the values, right. So, such that time will be saved, you can easily do it. So, I am just cleaning it, right. So, in that case, if you make all this conversion and make your series, your after making this, all this say some series combination will come. So, if you make it, it will come your 8.888 this side, right, because as soon as you will make it, that you will see that 24, 20, 10 are in your what you call in your what you call that your delta to star. So, it will become 13, and with that this is your 13 ohm, and this branch, because as soon as you make this star, as soon as you make this one what you call star connection, with the 13 something will be in series, right, and other thing, and other two will be that 8.88 will come. So, 4.44 will come, say it is your R1, say it will come like this. So, this is your after delta to star conversion, and this is the other two part 8.888 and 3.703. So, this 4.44 will be in series with 13, and this will be series with 30, and this will be in series with 50. Please do it of your own, right, please do it of your own. Actually, when you will make this one as a delta, just hold on, if you this thing, this is delta, no. So, forget about this thing, this 10, I am, if I make it like this is my 10 ohm, forget about this thing, for example 10 ohm, then this is your star, this is star, this is star, suppose this is your R1. So, whatever will come here with the 13, it will be in series, whatever will come here, it will be in series with 30, and whatever will come here, it will be series in 40. That is whatever you have got, 4.44, 8.88, another I have to see how much it is, right. So, that is the thing. So, anyway, cleaning this, right. So, this way it is coming. Now, this add these two, and these two are in parallel, because they are in parallel. So, if you, that is 38.888 and 53.703, these two are in parallel, make their equivalent, and this is 13 plus 4.4, 17.444, and their equivalent will be 22.555 ohm. I mean, it is something like this, right. It is your 38, they are in series, into 888, right, into 50 plus 3.703. So, 53.703, right, this one divided by 38.888 plus 53.703, it will come actually 22.555 ohm, that whatever it is made here, right. So, this, because they are in parallel, because this is your common node, this node is a common node. So, they are in parallel, right. So, let me clean it, right. So, now you add this to 17.44. So, you will find it is 40 ohm. So, if you add this, it will actually 40 ohm, right. So, and I is equal to then 50 by 40, 50 volt is the source. So, current is 1.25 ampere, right. So, thank you very much, we will be back again.